Instead of going to a river during a major flood event, Claire Masteller can create the force of a flood through this flume in her laboratory.
Then as we turn the flow up, they're going to start moving.
She increases the flow to 190 gallons of water per minute.
We really care about when this stuff starts to move. When the gravel starts to move, you're doing the work of erosion that's changing the landscape.
Masteller is an assistant professor in the Department of Earth and Planetary Sciences at Washington University in St. Louis.
I'm a geomorphologist, and so I like to describe geomorphology as the science of scenery. Here in Missouri, we get a lot of rainfall in the spring, and so we're interested in how the floods that run through our rivers in the springtime might act to change their shape or might cause some overflows and flooding.
If a riverbed becomes more resistant to erosion, large rainstorms might result in more flooding with devastating consequences. If a riverbed has severe erosion, the river will widen to accommodate bigger flood flows. Both situations spill over into social, economic, and health issues.
You have the erosion hazard itself of as the banks widen, you get bank collapse. If you have roads close to rivers, you can start undercutting those roads and really affect nearby infrastructure. As those banks collapse, they supply more soil and sediment into the river. That increased turbidity can affect fish habitats. Rivers are also an important source of fresh water, and so water quality is linked to how often rivers erode. So there are lots of reasons that you might want to care about a river and what it's doing.
Masteller is studying how rivers respond to climate change.
As our climate changes, size and the frequency of flood events change. How does that maybe lead to more or less flooding in some areas versus more or less erosion in some areas? So how will our rivers respond? We both care if a flood happens tomorrow, what's going to happen to our river. Now, the question is, what is the consequence if the same flood happens 10 times more frequently 20 years from now than it will tomorrow? So we're very early in that process, but that's where the experiments really come in handy, right? Because we don't have to wait around for climate change to happen.
She's using the flume to study the erosion patterns of rivers, in this case, a gravel riverbed. She can model rivers big and small, from the mighty Mississippi to the modest mountain streams.
And so we can change the slope of this. We can change if this is a bedrock river or an alluvial river, a river that has gravel in the bottom of it. We can change the shape of that gravel. We can change how big or small the floods are. So we can really model anything from a mountain river to a lowland river.
One example in Missouri is Johnson's shut-ins. Masteller's students conduct field research along with experiments in the lab.
The way that we would change it for Johnson's shut-ins is instead of filling it with gravel, we can put bedrock blocks in it, and we can then have gravel bounce on top of the bedrock, and we can measure how that bedrock erodes.
She combines the experimental studies with historical flood data and geospatial data. The study of varying river channels is supported by a grant of more than $300,000.
Funding to study river response to climate change comes from the National Science Foundation. There are lots of different knobs that you need to turn to be able to make predictions about what's going to happen when you think about climate change, but that's where our experiments can really help us gain some insight without having to wait for it to happen.
The research provides a foundation for river flood hazard forecasting models.
10-year, 20-year projections of if this is how our weather patterns and our climate is going to change in the next 20 years, here's how our rivers might respond. What we're trying to do with this study is develop a method to go to a real river somewhere and say, given climate change projections, given if this river's in the mountains or if it's in a low-lying floodplain, if there's snow around or not, how might this river respond to climate change? How sensitive is this river versus a river sitting somewhere else?